Greetings class, welcome back. In this video, we're going to focus on how we would implement procedures, functions in ARM assembler. And to start this off, we need to be introduced to two new elements. I wouldn't even say instructions, because only one of them is an instruction. The first is we want to look at this something called the branch and link instruction. Okay, we're going to use it as BL, branch and link. And this is how we call a function. Just branch and link, and then whatever the name of the function that we're assigning. Okay, pretty simple. All right, there's a little caveat of how it's used and what's going on under the surface that we'll talk about momentarily. Okay. In our return, when we're leaving a function, we're going to do something like this, where we move something into the program counter. Okay, so if you remember, the program counter is keeping track of which instruction we're currently running. All right, so if we have a program that has instruction 1, instruction 2, instruction 3, instruction 4, okay, the program counter is the register that keeps track of which instruction we're currently running. Okay, not necessarily always going in sequential order, right? Because you can have branches in here that cause it to potentially jump back up to a prior line. Right, program counter keeps track of which instruction we're running. Okay, so this instruction here, despite the name being LR, we're going to refer to this as, oftentimes you see this in other architectures as RA for return address. Okay, this is the return address, keeping track of what called the function. Right? Somewhere in the code the function was called. We need to return to that location. This keeps track of that location, and we're going to update the program counter to say, hey, jump back to this location. Okay. Now I'm going to trace this in a moment. Right? You're going to see this in action. We're going to actually look at the registers and see it. I think that will let it sink in when you actually look at a real example and you see that happening. Okay. So let's look at a real example. First, let's look at an example in C. This is something that you've seen before. We're implementing a is-even function, okay, in C. I did it using bit masking so that we can stick with all the, we can easily implement this in the instruction set that we've seen thus far in ARM assembler. Okay, it's basically doing a bit mask to 1. It's looking at that last digit. And if that last digit is a 1, right, we know it's an odd number, so we're going to return false because it's not even. Otherwise, it's true. Very, very basic function, very simple. Okay, and let's look at how we would implement this, okay, in ARM. Okay, now the first thing I'm going to do is let's ignore a lot of stuff. Okay, let's focus just on this. Okay, just on the body of the function. And instead of returning anything as a starting point, let's just make sure we understand the logic. I'm going to set a register equal to 0 if it's false. Okay, and 1 if it's true. Okay, underneath the surface, that's what a Boolean effectively is anyway. It's a 0 for false and a 1 for true. But we're not returning anything. We're going to ignore that temporarily just to kind of look at the logic. Okay, so this ARM code over here is not implemented as a function, right? Not yet. Okay, let's look at what it's doing first. We've seen stuff like this before. We're doing the bit mask. We're looking at, so we're taking the original input data. I'm saying R0 is going to be our num. We're going to mask that with 1. We're going to do a bitwise AND operation. Okay, we're doing a comparison to 1, just like over here. All right, and then if it's equal to 1, right, we're gonna set it to 0, just like false over here. Otherwise, it gets set to 1 for true. Okay, so we've seen all this stuff before. This isn't really anything new. Okay, now the question then is, how do we take the stuff that we've seen before, which, right, and have it actually work as a function. And to do that, as we mentioned prior, we're going to need to know that we're going to have to apply the knowledge of these two things here, the branch and link function and this move the return address register LR to the program counter. So let's go ahead and do that. And I've put in that code that we just looked at here in assembler. I've written it already. So let's go ahead and implement it as a function, right? And to do this, we're really gonna let's think about how we really have two functions, and just like we had over when we did this in C, we really have a main function and an is-even function, right? So we'll do the same thing in our assembly language, right? Let's have a main function, all right, and we're gonna have our is-even function as well, okay? Maybe, you know what, just to keep things simple, I'll put main up top. Right, we're going to take the body here of the is-even function. We'll put it down here. And, you know, let's make some real clear comments to indicate that here's our function. Okay. Here we'll have our main. Okay. So here's our code. We haven't really, this isn't going to do anything really yet. Actually, right now, if I ran this, it's not going to do anything different than it did before. It's going to just come down here. It's going to initialize R0 to 6, do the bitwise operations, and it's going to set, because it's an even number, it's going to hit this, and it's going to set R3 to 1, right? I can even run it and prove that that's indeed the case, right? I come over here, R3 is indeed 1. Okay, if I change this to some sort of odd number, I run it again, right? R3 is 0 for false. It's not even, okay? So, but we didn't implement it as a function, right? If I run this line by line, I'm using the breakpoint here, right? We see that it's here on this line. I step forward, right? It's just going line by line, right? It's not really implementing it as a function. There's never any return. It just runs straight down. Okay. Okay, so how do we build this as a function? Okay. So we have the name of the function already here, the label. Right, we've already seen labels. There's really nothing different here than just having the label, the name, okay? And I'm going to call branch and link to the name, okay? Now this here, branch and link, this is not the same as just doing, well, let me show you, right? You might wonder, well, why not just do a branch, right? Why not just branch, right? That will jump here. Okay, so let's imagine I have some other code. This is like other code after the function call, right? And then eventually we're going to have our exit. Maybe that just kills the program. I'm just having that jump to the last line, right? There's other ways to do that, but I could also do something like end, which is the end of the program, right? But, yeah, let's do that. We'll do end. So if I have some other code that happens after the function call, and just as an example, I don't know, we'll just do a few things. Just to kind of illustrate the point, right? When you have a function call, you can have other things happen after it, right? There's no reason this is going to be the end of the program. Right now, what will happen is we'll never run this, which is not really realistic, right? It's not realistic. If I go here, I step forward, right? We could see the branch jumping to here, right? I come down, does its thing, and we hit the end of the program, okay? That's not what happens in the real world when you're calling a function. Here I'm calling a function, for example. It calls that reusable block of code. When it returns, it continues running the next thing down here. And in fact, in this case, it would run the function again with a different input, right? And there's no reason we want that to be any different in assembly. Okay, so you might notice that the code looks formatted slightly different. I had a crash on me and just resurrected the code that didn't save, but it's the same thing we were looking at before. Just the comments might look a little different. And okay, so we have this branch statement that we were looking at that goes down here, but we're not actually ever running this other code, and we don't want that, right? Because we saw how we just talked about how that's not how C works, right? C is going to, or any other language for that matter, you call a function, it runs the function. When the function returns, it picks back up where it left off and continues to run, right? We have the same situation going on here, okay? So what we want to do is if we do something called a branch and link, okay? That link, what that does is it saves the return location, right? It saves the return address that basically says, hey, when this function returns, right, it's calling a function. When that returns from that function, right, it should continue picking up and running this next line here. Okay? So what I would like us to pay attention to when I run this again, okay, I'm going to run this again and to pay particular attention to the program counter, okay, and this LR, which is going to be our return address. Okay, so let me execute this. Okay, let's put everything in base 10 to keep it simple. Program counter is at 12. We're here on this line. I'm going to step forward. Okay, right. Program counter is at 16. Okay, right. Program counter is at 16. Running the next line here, and I stepped forward and noticed that it kept track of 12, right, where the function was called, right, and it's going to get updated, right? So if we kind of back up a second, so as I'm running this, if we look at the program counter, look at the program counter's value 12, right? Step forward, okay? The program counter is being updated. It's on the next instruction, and it's keeping track of the return address, where it's supposed to return. And now, it might look a little off here. Looks like it's -4 from what it should be. It automatically gets updated by 4 every time it runs to the next instruction. So this would actually get updated to 16. We're going to see that when the function returns, it's actually going to run this line here, this add, right? Because it's going to get automatically updated by 4 each time, okay? Now, the problem right here is I get to the end, we never actually returned anything, right? So we're updating the program counter. It's going to the next instruction, next instruction, next instruction, okay? But instead of here where we're moving, right, we're saying R3 equals 0, we actually need to return from the function, okay? And I could do that by taking that return address and updating the program counter to return, right? To basically say, hey, the new program counter is where it called the function originally, okay? So we were missing these lines before. This is the actual return. If we don't have these lines, okay, if we don't have those lines, it's equivalent to looking at something, say, in C, where we actually are setting some variable to false. It's kind of equivalent to doing something like this. False or 0, but never actually returning anything, right? So that doesn't really make sense when we're talking about a function, right? We want to actually return from the function. Okay, so we run this again. Now we have a working function, right? We're calling here. It's going to jump to the function block, right? We're updating the return address gets updated as soon as the branch and link saves that return address. It's doing its thing. It's doing its logic, right? And we've got here, we started with 7, so it's false, right? So we set R3 gets set to 0. And here's our return. Notice that here, right here, we're updating the program. We can see the branch is going to bring us back up here. And it knows that based on this return address information. Okay. Right. It knows that. And what effectively happens is it looks like it's minus, 8 less than it really should be. You got to remember that, there's some automatic updating happening at each instruction being executed. There's an automatic updating by 4 bytes each time, right? So you effectively, when it ends up running and setting it equal to that value, it's going to update it and it's going to land on the right instruction, okay? Which is this one, okay? And then the program terminates, right? If we went here, we set it to something even, we run it again, okay? Right, go down here, right, we're going to set R3 to 1, hit this, right? This is telling it to return, right? Remember, it's the instruction immediately after the function call is the one that should get executed, which is exactly what we see here, okay? All right, so that's an introduction to the branch and link and how we are using the program counter. We're manipulating the program counter when we return from a function, okay? The one thing we have not seen yet, which is going to be for the next video, is that if you recall from when you first learned functions in a previous course, that we want to treat functions like a black box, right? So that we have inputs coming in and outputs coming out, and that we can hide all the functionality in here, okay? And that's not really what's going on, what we've seen so far, because we have all of this registers being set, and there's all these dependencies going on where we have to, that we're using all these registers here, and we'd have to be careful not to clobber something that's being used up in a different function scope, right? We'll talk more about that in a future video, but there's some rules related to functions that we're currently violating, and we haven't seen how to get past those, right? But we will look at that, and we're going to explore that deeper in the next video.